Hi, in this video, I'm going to demo on how to do the analysis for question E, hypothesis testing of relationship between two ratio variables. There are several steps for these questions. First, you have to choose two ratio variables and determine the relationship. For correlation analysis, we will use correlation coefficient and scatter diagram. Make sure you choose the correct variable, which is the variable for RQ, the relationship between two ratio variables. For example, here we have age and saving per month. And in Excel, you have to define your variable. And to find correlation coefficient, to use is equal correl in bracket. You select the data, the range, and select comma, select the range of Y. You press enter. This is the value of R. From this R, you can determine the relationship. Next, to perform or to create the scatter diagram, you go to Insert, Chart, Insert Scatter. You choose the range of data for X and Y and you click OK. Make sure you fully label your scatter diagram. This page is all the information needed to test the significance of correlation coefficient. We will need the R. We will need the degree of freedom. The degree of freedom is n minus 2. Let's say for this one, we have 101 data, so minus 2, 99 is the degree of freedom. And to calculate the test statistic, this is the formula. We still use the same formula that we learned in our lecture, which is T equals to R multiplied with square root of n minus 2 divided by 1 minus R square. So as you see here, this E6, E6 is actually the cell of correlation coefficient. And is another E6 also the same cell, we square it. So it depends on where is your correlation coefficient value, depend on where is the cell. SQRT is for square root. If you want to use p-value method to find the p-value, this is the function or the formula to use, equal t.dist.2t. E10, E10 is actually cell of test statistic, okay, which is this cell of 5.9346 for this example. Okay, E10 is cell for test statistic and E8 is cell for degree of freedom. This is cell of T. All this information are needed to test the significance of correlation coefficient, the 5-step hypothesis testing. Next, you have to do a simple linear regression analysis to find the equation of the best fit line, means to find or to construct the regression equation. To use Excel, step 1 is you go to data and then you go to data analysis, you select regression. In the command box, in the Y range, you select the Y, including the title, and the X range, you select the data of the explanatory or the X data. You tick on the label. Confidence level, we make it 95% because our alpha is always 5% for group assignment. Output range is where you want your output to be. The rest, you can just ignore. Once you do this setting, you can click OK. Once you click OK, the Excel will provide you this output. We have regression, we have ANOVA, we have the detail of the questions that we want to construct. So the one that you have value, coefficient value for intercept and the x. Okay, the h for the example is the x. So from here, we can create the equation of regression line, which is it will be y equals to the coefficient of intercept plus y become plus because h, my coefficient here is positive. If negative, it become minus. Okay, x, and make sure you define what is x in your report or in your PDF. So in your report or PDF, you have to define your x and y. You have to provide the value of correlation coefficient and describe the relationship. You also have to create or put in the scatter diagram and to test the significance of the correlation coefficient. Okay, define your x and y and put in all the information, the R value, the degree of freedom, the test statistic, the p-value that you have got from the Excel, and perform the 5-step hypothesis testing. And for this example, this is by using p-value method. You can use also traditional method. And this is for correlation coefficient regression line. For regression line, make sure you put in the definition of the variable, paste in the output, and put in the equation. Okay, and make sure you have defined up here, so it should be fine. And that's it. That will be for question E. Thank you.